So last week we covered tyres. This week we've got the start of cornering. We'll be doing cornering next week as well, but this week we're just looking at low-speed cornering. So off-tracking, okay, which we call delta, that's the delta symbol, that triangle, is the distance between the radius of the path of the centre of the front wheels, which we'll call R, okay, in this case, and that of the rear wheels, which we'll call R, little r, for rear, okay. And so, as you turn a corner, okay, like I said, vehicle in plan view, if we assume that the distance between the centre of the corner and the centre of the front wheels is distance r, okay, the back wheels aren't going to track in the same path as the front wheels. Okay, they're going to take a slightly shorter radius, because obviously r here is shorter than here. And that angle there is our steering angle. Okay. It's the average of those two angles you get delta. And because of that, obviously, like I said, your rear wheels are going to track inside your front wheels, okay? And that's not so much of an issue in normal day-to-day driving, but clearly like manoeuvring the car around a car park and stuff, you need to make sure that when you turn the steering wheel, you get the corner of a car or something. And that's, like I said, that's called off-tracking. Okay? It's a bigger issue with like trucks and lorries with things with a very long wheelbase, because that's going to be more of an issue. Okay, the delta is going to be much bigger, because you can work out what delta is. Now, if you were to do some sums and some trigonometry, okay, delta clearly, this distance here, is going to be the difference between my radius of the front wheels and the radius of the back wheels. Okay. Now, radius of the front wheels, which is r, so we go on here. This value we can actually work it out, okay, based upon this one. Okay, this is an angle, we've got an adjacent, so it's coastline times by the hypotenuse. Okay, because r cosine delta will give us an r. Okay. So we've got the radius in both of those terms. Okay, so in delta we know is L upon r. Okay, so r times by 1 minus cosine of L upon r. So again, like I said, the wheelbase is featured in there. Makes a difference. Actually, it's just a corner radius. Now, you may have, well, you did contain a series of level 1, yeah? So cosine can be represented by a series of numbers, a series of coefficients that go off to infinity. And if you were you wanted to plot L upon r, okay, or cosine L upon r, you could plot it by a series of what obviously it continues on. You can see it's L squared over r squared times by 2 modulos plus L cubed times by r squared times by 3 modulos. And so obviously that number and that number are the same. But it goes minus plus and so on. If you just plot the number of these terms, it will look like cosine. And so what we do is we neglect the higher order terms, let's ignore the higher order terms, and we end up with delta being L squared upon 2r. And so notice that we've got 1 minus cosine, so another 1 minus and then L squared upon 2r. Okay, this is r squared. Doesn't matter, because that cancels the square root. So yeah, sorry, put that in there. Well, 1 minus 1, that disappears, okay? And then we've got minus cosine, so that becomes a plus L squared upon 2r squared, and obviously times by r, that's squared to 2, L squared upon 2, which is the okay? So you can see that the wheelbase has a massive effect, because you're squaring it, and then dividing by 2 times the radius, okay? So we've got a long wheelbase, that's squaring a bit even bigger, okay? The off-tracking is going to grow. Okay, so that's the next equation. Delta is a big delta is L squared upon 2r. Okay. So a truck has a wheelbase of 5.4 metres, okay, and a track of 1.486. This is quite a small truck. Okay, calculate the inner, outer, and average steering angles for a turning radius of 10 metres. Okay. Also calculate the off-tracking as the rear wheels negotiating this turn. Okay. So So here we have got a slightly longer wheelbase, okay, and a trash to 1.36. Okay, so do the same thing, calculate the inner, outer and average steering angles, okay, and also the minimum width of the track, okay, so all the road or whatever, per 10 metres. And you want to allow half a metre on either side of the vehicle for safety. Okay? So how wide does the road need to be for this vehicle to negotiate that corner? So think about what's going on, where the limits are.